Hey, Group 4. So I was really proud of the work y'all did on your quiz yesterday. For the most part, y'all only missed a couple of things. And they had to do with the problems that had sort of the tricky Roman numerals. For the most part, it seems like you knew when to use a Roman numeral, and you knew how to find the Roman numerals by uncrossing the crisscross. But when I gave you one that was a little tricky, those are the ones that y'all missed. So let me give you an example. The one that was on the quiz yesterday is PbO2. Now, the trick with this, ladies and gentlemen, is that we always reduce ionic compounds, right? So if I ended up with SN2O4, I'm going to reduce that down to SNO2. Now, when I uncross my crisscross, in the original one, which I got from the charges, the charge on tin is 4 plus because this 4 goes over there. But once I've reduced it, it makes it look like the charge is 2 plus, but it's not. So let's talk about how to figure out what the correct charge is when we're looking at one that's been reduced, like this PbO2. Okay, so what we're going to do is we're going to uncross the crisscross. So I'm going to take the 2 from oxygen and I'm going to put it back on the lead. I'm going to take, there's nothing here, so remember we always assume it's a 1. So I'm going to take that 1 and I'm going to give it to oxygen. Oxygen gets a 1 minus. And most of y'all successfully did that much yesterday on the quiz. But what you missed is this. If I go to my periodic table and I find actual oxygen, its charge is not 1 minus, it is 2 minus. Okay? So when I uncross my crisscross, I need to check the charge of the nonmetal to be sure it matches the periodic table. Because remember, those charges are permanent. Oxygen is always 2 minus. So this 1 minus charge I have here, that doesn't fly. I can't leave it like this because oxygen is never 1 minus. So what I'm going to do, how do I make 1 minus 2 minus? Well, I got to multiply it by 2. So I'm going to put my whole charge thing in brackets and I'm going to multiply it by 2. When I do that, oxygen ends up with its 2 minus charge, but lead gets a 4 plus charge. So what's my Roman numeral for lead in this case? It's 4. So this would be lead 4 oxide. Okay, so the second step on this is that if they don't match, you're going to multiply all charges so it does. Oxygen has to be 2 minus. So if we get a 1 minus for the oxygen, we multiply the whole charge thing by 2, and that gets me the 2 minus I need for my oxygen. Now the other thing that I saw a lot of people doing was messing up the crisscross when we're doing the tricky Roman numerals. Okay? So, for example, particularly ones that needed to be reduced, I saw a lot of failing to reduce. So like if I give you something like manganese 4, oops, that's cute, Miss Green. Manganese 4 oxide. Okay, manganese is not the same as magnesium. Those are different elements. Manganese is a transition metal with a symbol of Mn. Oxygen is O. Manganese, they've told us, is 4 plus. Oxygen, we know, is 2 minus. So I take the 4 from manganese, and I put it on the oxygen down here. I take the 2 from oxygen, and I put it down here. Now, can I leave it like this? No. It has to be reduced. So we're going to reduce it. What do I mean by reduce? Well, does 2 go into 4? Yes, it does. So I'm going to divide both of my subscripts by 2. So for manganese, that gets me a subscript of 1, which we don't write. For oxygen, 4 divided by 2 is 2, so that would be MnO2. So manganese 4 oxide would be MnO2. All right, guys, so you just need to work on the practice problems, share that on your blue paper, turn that into Miss Crane, and then you're good to go on today's assignment. Thanks for watching.